Hello. All right, wait for some more people to join. Day's going well. It's the best part of the day right now. Get to learn a little dilation review. Give everyone a couple minutes to join, and we'll get going. Josue, how we doing, buddy? Kiara, Samantha, hello. People just joining, welcome. Quarantine teaching, day 2, is it? I'm gonna do a little, move this back, little dilation review. Can you guys see that all right? Here, we'll be using here too. All right. Tatiana would not be sleeping today. All right. Should be a pretty quick day today for Friday. And then I put some new stuff, dilation tests that you guys can look at and go through. Yes, all dressed up. Nice. You guys probably. All right. So as we wait one more minute, we'll get going. Yes, I am. I got a better setup today. I got a whiteboard, a little lighting up top. Hope you guys can see better. And then, so I would just start copying this stuff down here, and then we'll do this together. Oatmeal is very good for you, so that's good. All right. Got 19, 20 people. Good, guys. Make sure you keep spreading our people, all right? Can't see the paper. It's too bright. Oh, it's too bright. All right, let me turn my lights off. What about? Is that better? Is that better? Ooh. What's up, Jaylene? There. It's just fine. All right, good. I decided to throw in some. There's Mr. Tolan. As you guys can see, Mr. Tolan joined the stream here. There he is. Mr. Tolan will be definitely be throwing up a live stream as well. So wait for his channel to get started. I'll let you guys know when he's all ready and set up. He'll be going live. Mrs. Hurd reached out to me. She gave me a website to share with you guys. It's like just like my Google site website, and she wanted me to share it with you guys so you guys can go check out that site. So I'll link that after we go over this. So that's it. All right. How many people we got? 26. We're growing. I like it. You guys ready? Quick Friday lesson, scale factor. I want to go over a couple things about how it changes the lengths and if it changes the angles. want to go over the rule again, and then we'll get rocking. And then I have a problem that I want to see if you guys can kind of figure out. I'll go with you after, but I definitely want to see if you guys can get it done, all right? Let's do it. All right, so yesterday we started with scale factor. All right, so scale factor is something that enlarges or reduces a shape, right? So we saw that yesterday, and here's the rule. So if you have the coordinate x, y coordinate, you know that you multiply each x, y point by whatever the scale factor might be, all right? So first thing I want to go over, because we didn't mention it yesterday, how does a dilation affect the length? Now, this is important. So if you guys are copying some of this stuff down, definitely write this down. So how does a dilation affect the length? Well, for those people that are thinking about this in your head or maybe trying to like write it down what you think, you probably came up with the idea that if a dilation enlarges or reduces a figure, what's going to happen? The lengths will, if the scale factor is 3, how much does it get bigger? It triples in size, all right? So if my scale factor is 3, the side lengths will change. And by how much? Whatever the scale factor is. So I'm just using 3 as an example. So if my scale factor is 3, then the lengths will triple in size. So it'll go from maybe 1 inch, scale factor 3, to 3 inches. So scale factors will change by whatever the SF is scale factor is. All right? So that's very, very important because when we were in school, guys, we did rotations, reflections, and then translations. And what happened to that image? It never changed at all. Like just the position or orientation, but the side length stayed the same and so did the angles. What you need to know about dilations, one of the most important things is this. The side lengths will triple or do whatever the scale factor is. That's how much bigger or smaller they're going to get. So that changes. So that's really, really important to know. The angles, if you're thinking about the angles do not change. So they stay the same. Angles do not change. They stay the same. Your angle measures won't change. The only thing that changes is the side lengths of the figure. So it's either going to get bigger or smaller, so they're going to get longer or shorter, whatever your scale factor is, all right? Yesterday we went over scale factor. If the scale factor is greater than 1, your image is going to get bigger. If it's less than 1, it obviously gets smaller. All right? So first example, we got it right here. So we got a little chart I made. And if you can see it, it has the pre-image, 2, 2, negative 2, 2, 1, negative 1, negative 4, 3. And then I have the image. And if you can't see it right here, I have 3x, 3y. Now, you should be thinking, what is this 3x and 3y? What does that mean for my new points, for my new image? Well, you should realize that 2, 2 is going to change by a scale factor of 3 because 3 is being multiplied to each x and y point. All right? Yeah, I would copy the board, Tatiana. Definitely this. This is really important, these two things. All right? And just use these as examples. All right? So, if you guys are doing this at home, 2, 2, if I have the rule 3x, 3y, you should all know that you're multiplying. So your new coordinate becomes 6, 6. Okay? Simple multiplication, all right? Next, we have negative 2, negative 2. What does that change to? Multiply by 3. Negative 6, negative 6. All right? 2 more, multiply. It's going to become 3, negative 3. All right? And then negative 12, 3 times 3, 9. And those are your new coordinates, all right? Simple as that. What's the scale factor? Everyone should know this. This is really not that difficult right now. The scale factor is 3. And how did I know it was 3? Well, it's in my rule right here, 3x, 3y. This is just another way of showing what the scale factor is. I don't necessarily have to tell you the scale factor every single time. It might be written like that, but since you're multiplying 3 to each of these coordinates to get your new coordinates, the image points, scale factor in this case is 3. All right? So, question for you guys. So just thinking about it wherever you are. Obviously, this is an enlargement, so my triangle gets bigger here. I'm sorry, my square here gets bigger. How much bigger will my new side lengths be? Now, if you're thinking about that at home, you got to think, okay, well, clearly my shape got bigger, so something changed. The length of the sides changed. And by how much, because that's what they'll ask on an exam or in a more in-depth question, it increased by 3 times the original lengths. So why is it 3 times? Because my scale factor is 3. So it got 3 times bigger. So that's as simple as that. So my side lengths changed, but my angles stay the same. Now, do you consider the pre-image to image to be congruent? Think about that. And everyone should say no, because congruent means the same. If it's not congruent, though, this shape is going to be similar. Okay, so make sure you copy that down. That when you perform a dilation, the shape is not congruent, but the shape will remain similar, but not congruent. Similar because if it's a triangle, it remains a triangle. The only thing that changes is that it's going to get bigger or smaller. So now it's going to be similar rather than congruent. Okay? So once you guys got that down, just let me know. And then we will do 2 more problems, and that's it. And you guys will just go onto my site and just check out what I put up there, right? Is everyone getting this so far? Pretty easy, right? Valerie, I have no idea. Right now we're off to April 1st, so who knows how much longer we'll be off for. All right, up to 35 viewers right now. Not bad. Yeah, Tatiana, exactly what we learned yesterday. Just going over in more detail about how they're similar. I didn't go over this yesterday, that the side lengths will change based off of your scale factor, but the angles remain congruent. Angles are exactly the same, okay? Diana, you're late. Ridiculous. -5 on your next assignment. Just kidding. Diana got this whole thing started. You guys ready? All right. We're adapting here. All right. Oops. Bam. You guys see that? Alba, what's up? Welcome. Mr. Tolan, you getting all this? And Miss Massaro is also supposed to join, and Miss Hurd, but they're late to the party. All right, so I would copy Copy these two down. Definitely copy this one down because I'm very curious to see who can figure this out. All right? All right, here we go. Start up here. XY becomes 1/3 X, 1/3 Y. So what's my, Miss Massaro, how are we doing? Taking my notes, very good. Yeah, everyone should be taking these notes down, especially this one when we get to it. All right, so 1/3 X, 1/3 Y. So everyone should know when looking at that. I didn't say what the scale factor is, but you know what the scale factor is because you have your normal coordinate XY being multiplied by 1/3 now. Now everyone should know 1/3 in their mind. If you're not good with fractions, just divide it in your calculator. 1/3 is what? 1/3 is going to be less than 1, so this image is going to get smaller. Who cares that it's a fraction? It's basic multiplication, okay? Now, Christina, what's up? All right, so 3, 3, 3, 9, 9, 3. We got a basic triangle here. Now let's take 1/3 X and 1/3 Y, and let's multiply to each coordinate, to each X point and each Y point. So here we go. 1/3 times 3 is going to be 1. 1/3 times 3 is obviously 1. So if this is A, B, C, so I'll put it over here, A prime. Let's go B prime. 1/3 times 3 again, guys, we all should know is 1. 9 times 1/3 is, what's 1/3 of 9? 3. And that is B prime. And these we already just did. What's 1/3 of 9 again is 3. And 1/3 of 3 is 1. That's C prime. All right. There are my new coordinates. Guys, if you have graph paper at home, please try to graph these. And you're going to notice this image goes from being a bigger triangle for the pre-image to a smaller image after you do the dilation because that number, that scale factor is smaller than 1. All right? So we got A prime, B prime, C prime right there. Now, what changes? Let's just keep hearing it from me and keep saying it to yourself, guys. What happens here? Well, my image got smaller, and what changed here? Okay, and now I know since my image got smaller, my triangle, the side lengths got smaller. By how much? By 1/3, because it's my scale factor. They will get smaller in this case by 1/3 because that's what we use as a scale factor to multiply to every point. Now, here's what the triangle probably would look like. It would go from looking like something like this, okay? And then when you regraph it, it would just be, look, exactly the same shape, but just smaller. So that's just a rough going here. But if you had graph paper, guys, hopefully in the coming weeks, I'll get a nice graph paper, bigger whiteboard, and then I can graph it and show you. But you're just going to notice it gets smaller, all right? And from here to here, it got smaller by 1/3. Do my angles change? Nope. Eli, get the lesson. Nice. Do the angles change? Stay the same. That's all cool. Just the side lengths. This is now, these triangles right here are similar. Not congruent, guys. All right, so don't forget that. They're similar when you dilate. Okay, they're the same shape, just a bit different because they are, in this case, smaller. Okay? What does the bottom say right here? Okay, so everyone's good with the top. I'm going to go down. I'll read the bottom nice and slow. So if you are copying down or you just need a couple words to write down because you just can't see it well, I will read it slow. Now, guys, hopefully, probably on Monday, because obviously I won't see you guys this weekend, probably on Monday, hopefully, I could talk to my brother because he does this as well. He actually there's a program where I can mirror what I have on my computer that you guys can see. So hopefully once I get that program installed, I can just mirror my smartboard right onto here so you guys can see it clear as day. Do they give you the number? So yesterday, sometimes, yes, they give you the scale factor every single time, but sometimes they don't give you a scale factor, but they'll give you these. So Schmoof, no idea who that is. You probably said it in the comments. If I didn't give you this, how would you figure that out? Oh, Roger. All right, Roger, good question. Watch how easy this is. So, Roger, pretend this is gone, right? No scale factors given. 1/3 wasn't given, but I gave you these points. Guess what you do? To find scale factor, or write it up here if you can see it. To find scale, I'll just write it right here. To find scale factor, you ready? SF, whoever remembers it yesterday, call it out. I know we can't hear you, or type it in. You do this. You do the image divided by pre-image. Okay? So that's how you find the scale factor, Roger, if it is not given. And how do you do that? You just go like this. What's my x-coordinate here? 1. Divided by my x-coordinate here is 1/3. There's my scale factor. And it works for every single coordinate. If it doesn't, then it's not a dilation, okay? Y, 1/3. What's 3 divided by 9? 1/3. So that's how you find scale factor, okay? Good job, Diana. Let's go. All right. To the last problem. We'll call it the hot problem of the day here. So let's get to it. Homework, it'll be on my website. I'll explain homework and stuff I want you to do for the weekend right after this. So here we go. I'll read this nice and slow. When triangle ABC was dilated by a scale factor of 2, the vertices of triangle A prime, B prime, C prime are A prime, -4, 4, B prime, -4, 6, C prime, 2, 4. What are the vertices of the pre-image? So I want to know what A, B, and C will be, knowing my image coordinates and knowing that to get to A prime, B prime, C prime, that my triangle was dilated by the scale factor of 2. So those are the important informations. I know that it was dilated by 2 to give me those coordinates. Now I kind of want to figure out what were my original pre-image points prior. Okay? So take a second. I want people that are, trying this at home to actually think about this for a second. I have my image points, my prime points, A prime, B prime, C prime. And how did I get these points? By this being dilated by a scale factor of 2. So if I want to get my pre-image points, look what I'm doing here, right? I have my answer. Now I want to figure out how I got to the answer. So I have to work what? Think about that. Think about that for a second. Does anyone want to maybe just comment what they think A would be if A prime was -4, 4, and we use a scale factor of 2 to get there? Josue, good job. Divide, good job. Backwards, good job, Diana. Yes. Liliana, look at you guys. It's kind of weird. I think you guys we're doing better video chatting here than in school. Good job, Diana. Eli, awesome. Guys, great. So then B would be what? Negative 2, 3. And then C would be 1, 2. There we go, Tolan. Good job, guys. Awesome. Really, really, really good. Guys, that honestly this was a question on a test that I gave last year, and this was a really tough question that stumped a lot of students. So the fact that people are kind of picking up on this in these tough circumstances is awesome. It's really, really impressive. All right. So the people that maybe got a little lost here, how did we get there? Well, if we knew my image points are here, right? And we knew that to get there, they use the scale factor of 2 to get there. You just got to think backwards, just like Diana said. All right? You work backwards. So if you know you need to multiply to find your image points, well, if I want to go to my pre-image points, do the opposite. What's backwards of that? Division. So instead of multiplying these by 2, we divided to get here. Because now watch. I'll take my scale factor of 2 to my pre-image points and watch what happens to my image. Negative 2 times 2 is what? Negative 4. 2 times 2 is 4, and so on and so forth. So that's how we got that answer. That's how you got your pre-image points, working backwards. Awesome that you guys saw that. That is basically it for dilation, guys. So that's as in-depth as we go here. So it seemed like everyone did really well with that. It seemed like you guys kind of followed along. Hopefully you were able to copy this down, get most of this. If you're still a little confused, guys, don't worry. Remember, these videos will get saved and put onto my channel, so you can go back and rewatch them if you are trying some of the worksheets that I give you. Yeah, so Roger, exactly. So it's basically mostly multiplying when they're giving you a scale factor. Just here you divided because you had to work backwards. All right. So couple announcements. So you guys good with this? So a couple announcements. One, let's keep spreading the word. All right. You guys have my YouTube channel. Please. Yeah, it's definitely easy. Good job. Please spread the word of this YouTube channel. All right. Tell the 8th graders, any 8th grader at this point. All right. Because it's tough, right? It's hard to get information out, but we're doing an awesome job of kind of spreading this word. Let's try to get more people subscribed, all right? I want to see that subscription go up every day. We need more subs here, okay? No, you cannot get it past the nurse. Also, my site, I'll send that link so that you guys, whoever's new here, can go to my site. What I want you guys to do this weekend, when you go onto my Google site, I want you to, there's going to be something called Dilation Worksheet 2. I want you to try that, and then I want you to look at the dilation exam. The dilation exam, I want you to open it. I want you guys to go through and see what you can do and what stumps you. If you're going through that and there's a specific question, hit me up on Remind. Let me know what was difficult. I'll try to respond back, or I'll make a video explaining some of the tougher questions. So we got to make sure that we're kind of in this together, guys. So the better we communicate, the better you get this word out, the more successful this is going to be, okay? The website, Eli, I'll get it right now. Also, if you guys aren't on Remind, it will be on my website. So make sure that you go and sign up for Remind so that you guys get the messages I send out. And my website is right here. How's everyone doing? All right, everyone hanging in there? There we go. And here we go. I'll post it right in the comments. Bam, there it is. Yeah. So there's the site. Go to that. We also have, hold on. One second, one more. Whoever has misheard, I'm typing in Miss Heard's Google site. This is Hurd. Go. Okay. Yeah. So hopefully, guys, I like this. I like this idea. I mean, we are growing, which is awesome. So, like I said, you guys got to spread the word. All right. I can do the most I can through remind and emails, but I think the best way to get it out there is through social media via you guys. So try to let people know to subscribe to this channel. So subscribe to Remind. Does Mrs. Cornell have Remind? I think so. I can ask her. I'll probably see her this weekend. So make sure, like I said, subscribe. Let people know. And that's how we're going to get this kind of to grow. So we did pretty well today. Let's keep this up. Good job today, guys. Have a good weekend. Stay safe out there. All right, stay healthy. Go on my website. Check out what I put on for Dilation. Just go through a little bit. You guys have any questions for me? So any questions before we kind of sign out here for the day? Any questions? Any questions? You guys good? Oh, thank you, Mr. Tolan. It means a lot. Yeah, thank you, Ms. Massaro and Mr. Tolan for tuning in. That was easy. That's great. Yeah, hopefully you guys are pretty easy. Like I said, this was an easy lesson. Start on Monday. We'll do something new. So I'm going to skip around a lot. Anthony, can you go to sleep now? No, I want you guys to maybe hit an at-home workout or something to keep your mind and body at ease. So one time, guys. Let's all stand up. Let's get up. And before we sign out, we're going to throw it up and we're going to hit it. All right? Let's do it together. We're in this together. Like I said, we're going to meet here at 12 o'clock Monday, 12 o'clock. Have a great weekend. And enjoy, guys. Stay healthy. Ready? Let's throw it up. See you guys later.